Colleagues, I am back with our part D. Part D, so far I have explored the dangers of ionic compounds. Next, we look at what? We look at our second substance was aluminium. Aluminium, which is a metal. So we explore dangers of metals. Now, the easiest danger which you can identify, metals are non-biodegradable. They are non-biodegradable. And also when you put a metal in water, that water will accumulate, as in those parts of a metal, they will accumulate in water. That water will not be safe for human consumption. Now you think about a case where iron is in water. You have parts of iron which have been disposed into water bodies. Do you think that water will be safe for human consumption? Do not be safe. Do not be safe. Therefore, for aluminium, the first point here it is excess accumulation of aluminium waste in water bodies. Now, where do these wastes come from? They can come from industrial processes. Now, industries that make saucepans made out of aluminium, those industries, they dispose components. They direct those components of aluminium into water bodies. So aluminium waste can come from industrial processes. So excess accumulation of aluminium waste in water bodies from industrial processes depletes oxygen levels within water bodies. And when those wastes are in water, still the water temperature and the pH will change. It will not remain the same. It will have to change. So it depletes oxygen levels within water bodies, changes water temperature and pH, hence making water not safe for human consumption. So we can still repeat our mitigation, practicing safe waste management practices of disposing of aluminium waste. Then other points of consideration, aluminium, I've said, aluminium is non-biodegradable. Metals are non-biodegradable. They are non-biodegradable. So aluminium is non-biodegradable, and when disposed onto soil or land, it takes long to decompose. This affects soil pH, soil structure, soil aeration, hence hindering plant growth. Why? Soil fertility will be lowered. Then you can also link aluminium wastes to toxicity. Now, these heavy metals, however, aluminium is not a heavy metal, but heavy metals like iron, which other one? Iron, zinc, you see? Iron, zinc, those that have higher molecular weights, higher molecular masses, atomic masses. Metals with higher atomic masses like iron, zinc, they are heavy. Then those metals which do not have higher weights, if it is not heavy, then it is toxic. So when you put a heavy metal in water, once that water reacts with it, over time, that metal will weaken, and it will weaken and it will break down into parts that will accumulate in water. So oxygen levels will go down, causing suffocation and hence death of aquatic animals. Then there are those that are toxic. Aluminium wastes. One can link aluminium waste to toxicity. Those metals of sodium, highly toxic, potassium, toxic. They can cause death of aquatic living organisms. So that is the case for aluminium. Colleagues, allow me stop this here and come back with the graphite.